Welcome back to another video of Jai Balaya series. This is a complete speed run, that is from starting from video 1 to video 24. Whatever I have covered till now, you are gonna get it in one compact video as I promised, and that will be starting after 2-3 minutes of this particular session. Okay, this is a very important session. This is regarding notes making, how to make notes for PPS or any subject, how to make notes. See, first of all, come out of the thought that you are in school anymore. మీ మార్క్స్ కి మీ స్కూల్ బుక్స్ కి కరెక్షన్ ఉంటుంది కదా, ఇలా నోట్స్ రాస్తే ఇలా టిక్ వేసుకొని టీచర్ చెక్ చేస్తుంది కదా. నో వన్ ఇస్ గోనా డూ లైక్ దట్. ఓకే, యువర్ నోట్స్ హ్యావ్ అబ్సల్యూట్లీ నో వాల్యూ ఇన్ యువర్ engineering. Understand this first point. Second point, the more amount of time you spend on making notes is directly equal to more amount of time you are wasting on yourself. So instead of making full such kind of notes, this kind of notes, I want you to make trigger notes. This is something called as trigger notes. E method use cheskuni nen BTech ni pass chesa. Okay, not just pass, I used to get more than 70% marks in every subject. Trigger notes. What you need to do is, first of all, understand how to make a trigger notes. See, I'll give an example. Meeku oka movie song chusna, movie dialogue vinna, automatically your brain will start imagining the entire thing that happened in the movie, right? In case nen Pushpa taggedele ante, you will start imagining one is wherever the dialogue came. First one, when the lorry dropped, వాడు వ్యాన్ తీసుకొస్తాడు కదా, ఆ సీన్ గుర్తొస్తుంది. ఆర్ ఎల్స్ ఇంటర్వెల్ సీన్ లో పుష్ప అంటే ఫైర్ అనుకున్నారా అని షూట్ చేస్తాడు కదా, ఆ సీన్ గుర్తొస్తుంది. ఆర్ క్లైమాక్స్ లో వెన్ ఈ కమ్స్ టు రష్మిక మండన్ పెళ్ళేయడానికి వస్తాడు కదా, ఆ సీన్ గుర్తొస్తుంది. దిస్ ఇస్ బికాస్ ఆఫ్ జస్ట్ వన్ లైన్, తగ్గేదేలే. దట్ తగ్గేదేలే యాక్ట్స్ యాజ్ అ ట్రిగర్. ఓకే, ఇన్ ద సేమ్ వే పీపీఎస్ కూడా, పీపీఎస్ కానీ బీడబ్ల్యూ కానీ మ్యాథ్స్ కానీ ఏ సబ్జెక్ట్ అన్నా కానీ you need some trigger words that will trigger the entire concept to your brain. Okay, and that trigger notes will be your this sheet. Okay, for every one unit you should have one sheet like this. So mattam 2 pages lo, 2 sheets lo, your entire mids one topic should be completed in this. This is how you make notes, not like this. This is only for class notes. You can't spend this much amount of time every day to revise. This is what is called as trigger notes. So now ask me how to make notes. Let me give an example. Let's say tokens. If I have to make notes, I'll show you how I make notes for C tokens. I write it as C tokens. There I just write one word, smallest unit, right? Ante. Tokens is nothing but the smallest units of C programming. Done. Okay, word lo ayipoyindi. The moment I see C tokens, I see smallest unit, my brain triggers. After that, AO, Arithmetic Operator. What are those? Plus, minus, star, divide, modulus. The moment I see this A1 arithmetic operators, plus, minus, star, divide, modulus, I can frame my own words. Arithmetic operators are used to perform mathematical calculations, and thus contains plus, minus, star, divide, modulus. Done. If you're going for relational operators, that is comparison, greater than equal to, less than equal to, not equals to, equals to. Done. Idi chuste ardham ayipotundi. This is how you have to make trigger notes in just one sheet. This is intalo. In this part, you can complete entire 1 unit of your notes if you know how to make it. Start practicing this skill for the next 4 years. This is how you have to make your notes before the preparations. Don't think that already sir నాకు notes ఇచ్చేసారు, నేను మొత్తం వీడియోస్ చూసేస్తా, మొత్తం క్లాస్ రివైజ్ చేసేస్తా, ఎగ్జామ్ ముందు మళ్ళీ ఈ నోట్స్ చూస్తా. Not gonna happen. It is not triggering you, it is giving you a bulk of memory. అది మీరు గుర్తు పెట్టుకోలేరు. You need some triggering point. So this is how you need to make the notes. Okay, so start making the notes in this pattern. Just before the day of exam, you should be holding only this sheet. ఈ ఒక్క షీట్ పట్టుకోవాలి, నోట్స్ ని కాదు, ఈ యూట్యూబ్ వీడియోస్ కూడా కాదు. Is it clear? So this is how you have to make notes, and this sheet is called as trigger notes. This is the best method to remember the things. Come out of your school mode, start writing your own answers, start making your own key points. Every topic should contain maximum of 5 lines, not more than that. Even if you write, for example, control statements, ankondam. Control statements, this is used to control the flow of execution. Done. Andulo first one, if else, else if ladder, ila okoka line lo rayali. Else if ladder, else. You have to write 4 syntaxes for 4 things. Done. చిన్నగా రాసుకున్నా కూడా చూస్తే అర్థమైపోతుంది సింటాక్స్. దెన్ యూ కెన్ స్టార్ట్ ఫ్రేమింగ్ యువర్ ఓన్ ఆన్సర్స్. ఈవెన్ ఫర్ స్ట్రక్చర్ ఆఫ్ సి ప్రోగ్రామ్, యూ కెన్ జస్ట్ పుట్ వన్ స్మాల్ బాక్స్ హియర్ అండ్ రైట్ వాట్ ఆర్ ద కంటెంట్స్ ఇన్ సైడ్. డాక్యుమెంటేషన్ సెక్షన్, లింక్ సెక్షన్, డెఫినేషన్ సెక్షన్, గ్లోబల్ డిక్లరేషన్ సెక్షన్, మెయిన్ సెక్షన్, సబ్ ప్రోగ్రామ్ సెక్షన్. ద మూమెంట్ యూ సీ దిస్ బాక్స్, మీకు అంత ట్రిగర్ అవుతుంది. దట్ ఈస్ హౌ యూ షుడ్ మేక్ యువర్ నోట్స్. This one sheet will change your life. ట్రస్ట్ మీ, దిస్ ఇస్ హౌ నీడ్ టు మేక్ ద నోట్స్. ఓకే, ఇది ఎందుకు చెప్తున్నా అంటే చాలా మందికి ఇంకా ఏమీ అర్థం కావట్లేదు అంట పీపీఎస్లో. బికాజ్ యువర్ మైండ్ ఈస్ నాట్ ట్రిగరింగ్ ద వర్డ్స్. మేక్ యువర్ బ్రెయిన్ ట్రిగర్ దెమ్ జస్ట్ లైక్ తగ్గేదేలే. ఆర్ ఎల్స్ ఐల్ టెల్ యూ వన్ మోర్ ఫేమస్ డైలాగ్ దట్ విల్ ట్రిగర్ యువర్ మైండ్. వాట్ ఆర్ దోస్? నాకు గుర్తు రావట్లేదు, సారీ. నాకు మూవీస్ గుర్తు రావాలి ఈ టైంలో. పవన్ కళ్యాణ్ ఉంది కదా, పవన్ కళ్యాణ్, ద మూమెంట్ హీ టేక్స్ హిస్ హ్యాండ్ టు ద నెక్. చూసారా పవన్ కళ్యాణ్ ది సిగ్నేచర్ మూవ్, హీ టేక్స్ ద హ్యాండ్ టు ద నెక్. ఆ సీన్ గుర్తు చేసుకుంటే మీకు ఫస్ట్ మీ బుర్రకొచ్చే ఫిల్మే డెఫినెట్లీ గబ్బర్ సింగ్. అది కూడా ఇంటర్వెల్ సీనే గుర్తొస్తుంది మీ అందరికి. దట్స్ ట్రిగర్ పాయింట్. ద మూమెంట్ ఐ టోల్డ్ హిస్ హ్యాండ్ ఈస్ గోయింగ్ టు ద నెక్, మీకు ఒక సీన్ మీ బ్రెయిన్ లోకి వచ్చి ఉంటుంది. దట్ కైండ్ ఆఫ్ నోట్స్ ఈస్ దిస్ ట్రిగర్ నోట్స్. ఓకే, స్టార్ట్ మేకింగ్ సచ్ కైండ్ ఆఫ్ నోట్స్. ఒక్క షీట్ లో, దట్ ఈస్ ఫస్ట్ పేజ్, సెకండ్ పేజ్, థర్డ్ పేజ్, ఫోర్త్ పేజ్, ఈ మొత్తం పేజ్ లో ఎంటైర్ 2.5 యూనిట్స్ రావాలి పీపీఎస్ ది. నాట్ జస్ట్ పీపీఎస్, దిస్ విల్ వర్క్ ఫర్ బీడబ్ల్యూ, దిస్ విల్ వర్క్ ఫర్ కెమిస్ట్రీ, దిస్ విల్ వర్క్ ఫర్ ఫిజిక్స్, అపార్ట్ ఫ్రమ్ మ్యాథ్స్ ఒక్కటి తప్ప, దిస్ విల్ వర్క్ ఫర్ ఎవ్రీ సింగిల్ సబ్జెక్ట్. Okay, start making notes like this. Now let's continue with PPS. Welcome back to another video of Jai Balaya series. In this video I'll be covering all the topics that have been posted till now in this YouTube channel, starting from structure of C program, then C tokens, then data types, input output operations, control statements, loop, functions and recursion, all in one video. Okay, even if in case you have not seen any of my video and you complete this entire video, this will match up with all the content that have been posted till date. And I'm posting this video to give everyone a warm overview of what you have done till now, and also a compact study material for PPS MIDS 1. Okay, this video may go, I don't know how long this video may take for me to complete, but I want everyone to just complete this video. And in case you get any doubt in this particular topic I'm explaining right now, like you got doubts in control statements and you want more explanation about control statements, go back to the video that I have posted regarding control statements and watch it completely. That will add up the things you have missed in this video. Okay, so let's start. So in this video, the first thing we are going to talk is structure of C program, then C tokens. In C tokens, I'll be covering all the 5 types: identifiers, keywords, constants, operators, strings. Then we'll be talking about different data types available in C programming, input output operations, that is printf, scanf. Then control statements. In control statements in C programming, we have 5 different control statements: if else, else if ladder, nested if else and switch. I'll be covering all of them. Then we'll be talking about iterative statements or looping statements, for, while, do while. Then I'll be giving you about functions, recursion, and we'll be writing a lot of C programs in this sequence. Okay, if in case you feel the video speed is much fast, then please reduce the speed to -0.75, and if in case you feel the video is bit slow, you can put it to 0.75, -0.75 plus 0.75 as per your comforts. Okay, so starting with C programming, as you all know, C programming is a high level or a mid level programming language, and it is a structured programming language. Structured, that is, as our human body has a specific structure, that is, we have our skull on the top, then comes our chest, then comes our legs. In the same way, C program has a structure. That is, whenever you want to write a C program, you have to follow a pattern that has been pre-described by the developers of C. Okay, that is called as structured programming language. That is, first you write the head, then you write the body, then you write the legs. You can't mismatch them, or else you will get some errors. This is the first problem with C. And the second one is C's execution. Whatever program you write, it starts from top to bottom. That is, from top to bottom, the execution will begin from the compiler. So if in case you first write legs, then you write head, then you write body, this doesn't make any sense, right? This doesn't make any sense. When you're talking about human body, the shape starts from head, then it starts from body, then it starts from legs. In the same way, we have to write a C program. For that, we have a structure, and that structure is called as structure of C program, which is a very important topic. Okay, structure of C program. If in case you know what is the structure of C program, you can write any program of your choice without any trouble. Okay, this will be the easiest thing that you can do. So structure of C program, I'll explain this what it is. It contains 6 parts. Okay, it contains 6 parts. For that, you need to draw a table like this. Okay, the first part is called as documentation. I'll explain them one by one. First, let me complete the diagram. The second one is called as link section. Okay, this is also known as preprocessor section. The third one is called as definition section, okay, where we define the values of the variables. This is definition section. And the fourth one is called as global declaration section. The fourth one is called as global declaration section, okay, where we declare the global variables. And the fifth and the most important section is the main section, okay. And the sixth one is called as subprogram section. I'll be explaining what it is one by one now, okay. I'll explain with an example. See, what happens is in the documentation section, we write the content of, or we write a manual for the program that we are going to develop. That is, if you are a C programmer, let's assume you are a C programmer and you are working in a very big company like TCS, Mahindra or Wipro or whatever it is, Dell, Wipro, Google. Imagine your dream company, okay, and you have developed a 1000 to 2000 lines program. 1000 to 2000 lines of program you have written, okay, and then you leave this company. You feel that, okay, I am done with this company, now I got a better opportunity, I should leave this. So the next person who is gonna come up and take up your project will not understand what you have written, because everyone has their unique way of developing a program, the way how I am talking. And when we are given a same topic, let's say we have given an assignment that talk about what would you do if you become a prime minister. You will talk in your perspective, I will talk in my perspective, right? It's not equal. In the same way, when a person is writing a program, he will develop as per his comforts, not on other comforts. So to tell people that what your program is writing, we will document. In documentation section, we will write the title of the program, the variables that have been used, what is the content of this program, what this function is gonna do, what each of the line means. So we will give a broad overview. Like when you buy a new phone, when you open the box, there will be something called as user manual, right? In the same way, every save program will have a documentation part where you will document the motive of the project, the date when it was started, whatever you want, okay? For that, the best example is you can write this program is to perform addition of two numbers. It takes two variables, then perform C is equal to A plus B, then print. This is a small example for documentation, okay? So where you write what you want to do. And the second one is link section. Link section is also known as pre-processing section, where we write the predefined header file names. Pre-processing, whatever it is, I don't know the spelling of pre-processing. So this is the section. This is the section where you write the names of the previously defined header files, so that whenever you want to use, let's say you want to use something called as printf, you will get to know the meaning of printf. If you don't know, chill, okay? If you want to use printf, the meaning of printf will not be known to the compiler by default. So you will have to specify an header file that holds the meaning of printf, like hash include stdio.h, okay? This is the section called as link section, where you will write all the predefined pre-processing statements. That's it. And the third one is definition section. Definition section is the third part of structure of C program, where you can define the values of a variable. You need not write it is a float, it is a char, it is a int, whatever it is. You need not specify a data type. Don't worry about data types. You will get to know here, okay? For now, imagine you just have to write the keyword hash define, okay? This means I'm defining some variable, and then you have to write the value of the name of the variable. It may be pi, and after that give a space and write the value 3.141596227, whatever it is. So by doing this, you will define the value of variable pi in the definition section by default. So you don't have to write the type of data type it is. The compiler will itself understand. This is called as definition section. So first one is documentation section, where you document the motive of the project. Then you write the link section, where you write the predefined header files. And third one is definition section. And the fourth one is global declaration section, where you will declare the variables outside the scope of main, which can be accessed either by subprograms or by the main program, okay? All the user defined programs as well as the main program can access this. Such kind of variables where the scope should be unified throughout the program, those will be defined in global declaration section. And how you define them? Write the data type, write the variable name. That's it. You will get to know when you write, when I write the program, you will get to know, don't worry. And the fifth one is main section, and the very, very, very important section. Main is the stomach of C program, okay? Main is the stomach of C program, from where the digestion starts. Without stomach, whatever you eat, there is no meaning for that. Until the digestion doesn't begin, no matter what food you eat, it's not gonna work out for your body. In the same way, main is the stomach of C program, and this is where the execution really starts. This is the starting point of the execution of C program, okay? And it contains variables, Inside the scope of main, there will be variables, there will be some statements that you need to be executed, there may be a return statement. Okay, you will get to know what all are this, don't worry. For now, just understand that main is the stomach of C program, from where the execution of C program really starts. Okay, and it may have some variables, it may have some statements, it may have some return values. Sorry, I'm just checking if Bluetooth is connected. Fine. And the last one is subprogram section. The sixth and the last section is subprogram section. In case of subprogram section, user defines his own functions. Just like main, a user can define his own custom functions like void add, which can perform the addition of two numbers. He can write void sub, he may write ptr, he may write whatever functions he want. Okay, such kind of functions which are defined by the user are called as subprograms, and these are a part of our main program. So that's the reason it's called as subprogram section, where the user defines his own functions. So based on this, we can write a C program. Okay, based on this, we can write a C program, and this is the structure of a C program. You can't write main section first, then write the link section in the bottom. No, this won't work out. As I told, C program follows top-down approach. So C program execution will start from the top and it will come to the bottom. That is the reason we have to follow a structure. This is the structure of C program. Please memorize this. Documentation section, where you document the content. Link section, where you write the pre-processing header files. Definition section, where you define the values of the variables. Global declaration section, where you declare some variables that you need to be used throughout the program. Main section, the most important part of the section, where the execution really starts, and this is the inbuilt function, and this is the mandatory part. Even if you don't write any of this and just write the main, your C program is gonna work. Okay, and the subprogram section, this is also not mandatory, but this can be used to define user defined functions. So this is the structure of C program. I guess you people are clear with this. After half an hour or after 15 minutes, I will start writing a program using structure of C program pattern. Okay, for now, let me complete C tokens, data types, and input output operations. Only then I can write a program. Fine. So the next one is identifiers, C tokens. The next topic is C tokens. What are C tokens? C tokens are nothing but, before we talk about C tokens, what is an atom? You people will be knowing what is an atom. Chemistry. Atom is the smallest unit of this universe, right? Whatever we call, atom is the smallest tiny element of the universe which can't be subdivided further. That was the definition, but Rutherford found out protons, electrons, and neutrons inside it. So atom is not the smallest particle, but technically, yeah. In the same way, C tokens, these are the smallest unit of a C program. These are the smallest units of C program. All these units together form a C program. Okay, these are called as tokens, and there are 5 types of important tokens. The first one is identifiers. Identifiers are nothing but the names given to the variables. That is A, B, C, D, sum, or it may be subtraction, or it may be product, whatever it is. It may be name, it may be roll numbers. So nothing but identifiers are the names given to the variables distinctly to identify each of the element individually. That's it. For example, you have roll numbers. Roll number 1, 2, 3, 4. When I call them, each one of your person is going to respond to that. Yes sir, yes sir, yes sir, yes sir. No two persons will have the same roll number. In the same way, no two identifiers will have the same name. That's it. This is about identifiers. And there are 3 conditions that you need to follow to write the identifier. Okay, the first one is an identifier can start with the alphabet. Second one, an identifier can start with the alphabet and follow with numbers if you want. Third one is an identifier can just contain alphabets. And the fourth one is an identifier can start with an underscore. Okay, that's also there. But the fifth one is an identifier cannot start with a number. These are the valid types of writing an identifier. That is, it may start with a single variable, single letter. It can start with a letter followed by numbers. It may only contain letters, or it can start with underscore and contain letters. And last one is you can also write like this, sum 21. This is also allowed. Okay, the first and the last condition is it should never start with a number. These are identifiers, just like your roll numbers. Every identifier is different, and every identifier will identify one particular element distinctly. And the second one after identifiers, what we have is called as keywords. Keywords, okay. Keywords are nothing but a sequence of characters, that is characters ante enti A, B, C, D, so on. Every single letter forms a character, okay. Every single letter forms a character, and a sequence of characters, that is ABC or Pavan or programming, these are known as keywords, that is sequence of characters, okay. And what are keywords? Especially in keywords there are two types. One are inbuilt keywords, and second one are user defined keywords. The first one are inbuilt keywords and the second one are user defined keywords. Let's talk about inbuilt keyword first. In case of inbuilt keywords, what happens is the meaning of the keyword is already been predefined in the compiler. You can't use them as an identifier. Like example, main. When you write main in C compiler, the color of the main is gonna change. If you write int, the color of the variable name is gonna change. If you write float, the color is gonna change. If you write break, the color is gonna change. So if in case the color changes when you write some name for an identifier, such kind of things are called as keywords. And each keyword has a particular task to perform. For example, if you write int, this keyword will help you to initialize the variables of the integer type. If you write float, this kind of keyword will help you to initialize the variables of floating type. If you write main, this will initialize the main function. If you write break, with this will help you come out of the main, sorry, it will help you come out of the loops, okay. So these are called as keywords, inbuilt keywords, where the meaning is already been predefined, okay. And there are totally 32 inbuilt keywords. There are 32 inbuilt keywords in C programming. I would like to say a few for you now. The first one is definitely main. Main is an inbuilt function, okay. Is the main an inbuilt function? Are you sure? I am not sure if, yeah, main should be an inbuilt function. The second one, integer. The third one is float. The fourth one is char, right? These are all the inbuilt keywords and these are all the basic data types. Next comes if, then comes else. You will get the meaning further in this video. And as you go on, there are 32 different keywords. Okay, I'm not sure if main is the keyword or not. I believe main is a keyword. So there are 32 different keywords, and if you go to keywords video that I have posted in this YouTube channel, you will get a clarity on this, okay. And I don't want to waste my time explaining this silly keywords. You can just go to the keywords video that I have posted and you can watch them all. This is about keywords. Keywords are nothing but a sequence of characters where the meaning is already been predefined by the developers of C program, and there are 32 inbuilt keywords. What are user defined keywords? You can define some variables called as add as per your comfort. So you can write your own function, right? Like void add, if you people know. This is also a keyword now. This is also a keyword just like main, but this was created by the user, which makes this a user defined keyword, okay. This is the second type of C token. And the third one is constants. Constants are nothing but the variables whose value is not gonna change throughout the execution of the program. Constants are the variables or the values that won't change throughout the execution of C program. Clear? And the keyword that is used to define a constant is const. Okay, const. Then you write the data type. Then you specify a variable, say constant a int 10. So the value of a will not change throughout the program. That is what a constant means. Okay, and there are literal constants. Literals are nothing but numbers. That may be integer, float, and there are 3 of them. And in also literal, I'll repeat again. There are different types of constants. The first one is literal constants. Literals are nothing but numbers: 1.1, 2.1, 3, 5, 72. These numbers are not gonna change. And the second one are called as character constants. Single letter written inside the single quotes, A, B, okay, A, B, D, F. These are called as character constants. And third one are called as string constants, which are sequence of characters written inside double quotes. If you are writing a string, you have to write it inside a double quote. And there is something called as backslash constants, that is backslash B, backslash T, backslash N, where the meaning, there is a special meaning for such things. These are called as backslash constants, whose meaning can't be changed. Whenever you write backslash and printf, you will get a new line. Whenever you write backslash T, you will get a tab space, right? These are all called as constants, the meanings which is not gonna change throughout the execution of program. And to get more clarity about constants, you can watch the constants video. And operators, one of the most important topics, so I'll explain this in depth. Operators are the special symbols operators are the special symbols that help you perform some operations. In that, the first one is arithmetic operator. Okay, arithmetic operators help you perform arithmetic calculations, that is plus, minus, into, divide and modulus. Plus will give you the sum of two numbers, minus will give you the difference of two numbers, star will give you the product of two numbers, slash will give you the division of two numbers, that is you will get the quotient, yes, and the modulus will give you the remainder. This will give you the quotient and this will give you the remainder. These are arithmetic operators. Okay, there are something called as relational operators that is used to compare two or more numbers, that is less than is a less than b, the second one is a less than or equal to b, the third one is a greater than b, the fourth one is a greater than or equal to b, fifth one is a is equal to b. If you want to check if two numbers are same, you have to use double equals, and a is not equal to b. These are called as relational operators. The first one are arithmetic operators, which will give you a value, but in case of relational operators you will get only two numbers. If the condition is true, you will get the value as 1. If the condition is false, you will get the value as 0. These are called as relational operators. The third type is called as logical operators. Logical operators are used to check if either of the one condition is true. That is, first one is AND operator. You people know what is AND. If both the given conditions A and B, both condition A and B are true, this will become 1. Or else if either of the one condition is false or both the conditions are false, you will get 0 as the answer. This is AND. The second one is OR operator. In case of OR operator, either of the one condition is true, the condition will be held as true. That is, if both are true, the condition is true. If A is true, B is false, the condition is true. If A is false, B is true, the condition is true. But if both the conditions are false, you will get it as 0. And the third one is NOT operator, logical NOT. In case of NOT, what happens is, if A is false, if initially A is false and you are right, not false, that is not 0, the answer will be returned as 1. If it is not 1, the answer will be written as 0. These are logical operators, AND, OR and NOT. And the fourth one are bitwise operators. Bitwise operators are used to perform mathematical operations. Okay, if you write 2 and 3, what happens is 2 will be converted into binary. I believe that is 1 0. If I'm not wrong, 2 is 1 0 and 3 is logically binary 1 1. So AND operator will be performed, and you people know 0 0 is 0, 0 1 is 0, 1 0 is 0, 1 1 is 1. So logical AND for 2 and 3 will get the answer as 0 1, that is 2. Okay, you won't get 1 0 as the answer, you will get a number. This is for 2, this is for 3. So 2 and 3, the answer is 2. In such cases, we have multiple bitwise operators. The first one is AND operator, the second one is OR operator, and the third one is NOT operator. The fourth one is XOR operator, and the list goes on. I am unable to recall the names. Yeah, there is something called as NOT operator, etc. These are called as bitwise operators. Okay, and watching the operators video, you will get a very good clarity on this. And the next kind of operator is called as assignment operator. Assignment is nothing but assigning the value, and the operator mostly used is equal to. If you write A is equal to B, the value of B will be copied to A. This is first type. And the second one is plus or equals A equal to B. Here what happens is A will be assigned the value of A plus B. Okay, this is sum and assign. The second operator is subtract and assign. The third one is multiply and assign. The fourth one is divide and assign. These are the 5 main important types of assignment operators. Okay, so we have covered arithmetic operator, relational operator, logical operator, bitwise operator, assignment operator. Then the other important one is increment / decrement operator. So in case of increment and decrement operator, what happens is you will write plus plus and minus minus. That is, if you write A plus plus, if the value of A is 5 plus plus, the answer will become 6. Okay, in the same way you can write A minus minus, the answer will become 5 minus minus, the answer will become 4. This can be pre-decrement or post-decrement. That is, you can write like plus plus A or A plus plus, minus minus A or A minus minus. Always remember in C programming, if in case you have some increment operator, the execution will go like this. Okay, from right to left. That is, A plus plus, first it will become 6. first it will become, the value will turn into 6 if it was 5, then the mathematical operations will be calculated. Or else if it is a plus plus, first the value of 5 will be taken to perform the mathematical operation, then the value will be converted into 6. So if you want more clarity on this, you will have to work on expressions. Okay, I don't want to explain expressions here, or else your brain will become burji pav. Your brain will really become burji pav. But I'll give you an example. Tell me the answer. A is equal to plus plus a plus a plus plus, where a is equal to 2. So if we have to solve this, what happens is, initially the value of a is equal to 2. As I told, if there is increment or decrement operator, first execute from left side. So the value of a, when it comes to a plus plus, the value of a becomes 3. Okay, the value of a becomes 3, plus we have plus plus a, the value of a is taken as 3. The value of a is taken as 3, then it will be converted into 4. Then the value will be converted into 4. So answer for this one is 3 plus 3. The answer is 3 plus 3. I am not sure. I may be wrong. So forget. This is a very complicated topic. I don't want to waste my time in expressions. I am really bad at expressions, so I can't give the answer. Try chesa raledu. Forget about it. Forget. So these are the different types of operators. Okay, see, when it comes to expressions, very few people can solve them. I'm really bad at it. I'm sorry, so I can't explain that. And the last one is strings. Strings is nothing but a sequence of characters. If you know the operators, that's enough. Mathematical expressions, if you want, you can learn from somewhere. I'm very bad at solving them. I'm sorry. And the fifth one is strings. Strings is nothing but a sequence of characters like P, A, V, A, N, double quotes. Strings are written inside the double quotes always. Okay, and a character, single letter, is written inside single quote. Just the difference. Strings you will get to know in unit 4. Okay, that is in the second series, complete C programming series part 2. I'll explain what are strings in depth. Okay, so now let's talk about the data types. I'm sorry, 1 second. Now let's talk about data types. Data types are nothing but the keywords that will specify what type of data will the variable hold. Like if you have written a variable a, and if you write int a, then this variable can hold all the integer types of values. That is, it may hold -1, -2, 1, 2, 27, 37, 47, whatever it is. So such kind of things are called as data types. Okay, that specify the type of data the variable can hold. And there are many types of data types available in C. Just give me a second, I'll explain them. I just need to drink some water. Yeah, I'm sorry, by mistake the video got ended. Yeah, data types, as I told, it is used to specify the type of data that the initialized variable can hold. Okay, and in C programming we have multiple types of data types. So let's start. The first one is short int. Okay, the size of the data type is 2 bytes. That is, 2 bytes of data will be allocated in the main memory. The format specifier is HD. What is format specifier? Like if you want to print a variable called as a, if you want to print the value of a, which is an integer, you will have to write something like this, %d, comma a. You will get to know this in input output operations. Just you need to specify the format specifier that we want. I'm sorry, I'll repeat. So in the printf, if you want to print the value of some variable, or in scanf, if you want to take the input of some variable, you will have to write the format specifier of that particular variable that you initialized. So the compiler gets to know what kind of input is it expecting or what kind of output it should give. To tell the compiler that what kind of the variable is a, we use format specifiers. Okay, so the first one is short int. The amount of bytes required in memory is 2, and the format specifier is HD, and the range, the maximum number that it can hold is 32,768 to positive 32,767. This much of detail is not required. If you know 1, 2, 3, it's enough. The second one is integer, which is of 4 bytes and and the specifier is %d. The third one is unsigned short int. I'll tell you what is unsigned now. Unsigned short int. When you use the word unsigned, all the variables can hold only positive values and no negative values. Okay, only positive values starting from 0 to positive. Okay, so in unsigned short int, the range is from 0 to 65,535 something. Okay, and the format specifier is %hu, and the fourth one is called as unsigned int. This is unsigned int, that was unsigned short int. This is unsigned int. The symbol is percentage %u. And the fifth one is long int, and sorry, the type is 4 bytes, and it is percentage %ld, and it can hold negative as well as positive values, but it can hold a very long range. If I have to tell you the number, it is from -2 147 483 648 to +2 147 483 647. So it's not possible for you to remember the ranges, so just forget about it. Long int. And next one is comes character, which is %c, 1 byte. Then it comes unsigned character, which can hold positive numbers. Unsigned char, that is also %c, okay, percentage %c, and it is also 1 byte. Next comes float, which is an important data type, float, that can hold decimal numbers, and the size of float is also 4 bytes and %f. And the ninth one is double, double. This can also hold decimal numbers. It is of 8 bytes, and the symbol is %lf. And the 10th one is long double, which is, I don't know what is even the size of long double. It is 16 bytes, and the symbol is %LF. Okay, so these are the data types available in C, where the important ones that you should remember is integer, which can hold numbers both negative and positive. The second one is float. It can hold only full numbers, not fractions. Float can hold both decimal, it can hold decimal numbers, both positive and negative. And the third one is character, that can hold letters or well as numbers, AB or 1, 2 or whatever you want. Okay, so these are the most 3 important types of data types. And as I told, data type is used to specify what type of variable are we using, and format specifier is used to inform the compiler that what kind of input is coming to it or what kind of output are we expecting. So these are the different types of data types, which is a theory concept. Okay, bakwas, bilkul bakwas. You just have to know integer, float, char. So I'll give you example. You will have to write int a comma b, which tells the compiler that a and b are the integer types, and it can hold the values from this particular range. And in the compiler, in the main memory, in the RAM, I will have to allocate 4 bytes. This is the use of data types. Okay, and in printf, okay, forget printf, scanf, I'll tell in input output operations. Done. So after data types, what is the concept? Now we come to input output operations. Very good. Now we are in input output operations. So I'll tell you now what it is. So input operation is, we are trying to give the inputs to our program. Okay, for that the function we use is called as scanf. Scanf is a function which is used to give input to the compiler or input to the C programming software that you are using. And the syntax is scanf. Okay, inside the double quote, you will have to write the format specifier, the type of input you are giving. It may be %d. Okay, if you want to give an input called as %d, an integer type, write %d, double quotes, comma. That is, you have specified a variable called as int a. Now you are giving input to int a, that is to the variable a. When you wrote int a in the RAM, 4 bytes of memory, you know now integer means 4 bytes of memory. 4 bytes of memory space is allocated to a, and this particular block is been created for a, where we can store the value. So this particular address should be given to scanf. So you'll write and, that is telling the address, store the value in this particular address block. And what is the name, what was the variable that is storing this address? A. So this is how you will write to have scanf %d and a. If in case there were two variables int a comma b, you just have to write scanf %d, write the format specifier, then and a comma and b. What if, so this is how you take inputs into scanf. What if there was something called as float c, int a comma b and character d. Now you want to take input of all 4, just write the same method, scanf. First write for float, so it is %f, then write for 2 integers %d, then write for character %c. I have dictated the format specifiers above in the data types, you can go there. So what is the variable for float? And c, comma, and a, comma, and b, comma, and d, bracket close, done. This is scanf. This will help you to take inputs into the program. Okay, the second operation is output operation. Output operation is used for us to see the output, that is in the display in our monitor. We have to see some output, right? For that, the function we use is printf, an output operation. Printf is the function, and in printf we have two types of syntax. In scanf there was only single syntax, that is scanf double quotes comma close. This was the syntax for scanf, but in printf we have two syntaxes. Understand focusedly. First one is printf double quotes. Here in this gap, whatever you write, the same thing will be popped up into the screen. That is, if you write printf and hello, printf and hello, in the output screen you will see hello. Same thing. If you write printf in double quotes, you write ax 2y dz whatever, meaningless, you will see the same thing to be printed out in the output screen, ax 2y dz. Okay, this is the first type of printf. What if you have a variable called as int a, you took the input using scanf, you gave the value as 50. Now you want to see the output in the screen. You want to see 50 in the output screen. That is, you want to see something like this: a is equal to 50. For that, you need to use the second type of syntax. For that, what you need to do is printf, okay, a is equal to, you need to show 50. For that, you need to write the format specifier of the variable a, which is of integer type %d. A is equal to %d, close the double quotes and put the comma. And what is the %d? What variable value you want to print? You want to print the value of a, so write a like this. Okay, another example is printf sum is equal to %d. Okay, you want to print something called as sum. Let's say you have two variables, a is equal to 50, b is equal to 60. You will have to write a plus b. So 50 plus 60, 110 will be printed as sum is equal to 110. If you write something like sum is equal to a plus b, that's it, sum is equal to a plus b in printf, you will see output as sum is equal to a plus b and not sum is equal to 110. For such things, you will have to use format specifier. So now I guess you people understood why did I dictate %d, %f, %u, %ld, %ld, right? This is because in printf and scanf, wherever you want to give the input or you want to see the value of the variable that you gave as output, you will have to use format specifiers. Okay, and every format specifier will tell two things. The first one is what type of data is it? Is it an integer, a full number? Is it a float? Is it a decimal number? Is it a char? Is it a letter? Okay, that is the first part of format specifier. And the second thing is you can specify the place where the value need to be printed out. And after that, you will have to write the variable names after the comma. If you are giving the input, you will have to specify address of the variable. And if in case you want to print only the value, you will just have to give the name of the variable in printf. So here in printf we don't have and, only in scanf we have and. Okay, these are the two input and output operations available in C. This completes our first part of our challenges, that is we completed structure of C program, we completed identifiers, keywords, constants, operators, strings you will see in the next video, don't worry, data types and input output operations. So before going into the next topic, I want to show you how to write a C program. Okay, so let's write a C program to add two numbers. Using the structure of C program. So using the structure of C program, I'll write this program. So now you will sync it with that. Okay, the first one is, so let's start. The first task is documentation section. For documenting, you will use to write comment lines, so that whenever you write comment lines, that is /, the compiler will skip this line, it won't execute this. Okay, and if you want to write multiple line comments, the keyword is /* and end it with //. So whatever you wrote here, the compiler is not gonna execute. So now documentation section, document it. Program to add two numbers. to add two numbers. That's it. You can also continue. Take input a comma b. Take input a comma b. Fine. A comma b. Perform a plus b and print sum. Whatever you want, you can write in your own words. I'm just writing this. So now after that, what comes is link section. So now understand, both printf and scanf. Both printf and scanf, the meaning of these two functions are written in a header file called as stdio. That is standard input output header file, stdio.h. So whenever you want to use printf and scanf, you will have to specify this header file, and that will be specified in the link section, which is the second important section. And the keyword used to include a header file is #include. You will have to write #include before adding any header file, and in less than and greater than symbol space, you will have to write the name of the header file, stdio.h. Is it clear? This is link section. #include stdio.h, done. And the third one is definition section. Okay, definition section, where you can define the value of a variable. I'll define one variable for you. #define. I'm defining #define a, the variable a, that is I have to perform addition of two numbers. A is equal to 50. Done. This will define the variable a and the value is 50. Done. And next one is global declaration section, where you can define global variables. I'll declare a global variable called as int sum. Int sum. See, I have defined the variable called as sum that will hold a plus b. Done. Next section is main section. I am writing int main. So main, you will have to specify the return type. In the functions chapter, you will understand what is the meaning of this. For now, just remember this. Open this. Now see here, I have defined the variable a. I have also declared the variable sum. The only variable I didn't declare is b, so declare it here, int b. Done. Next, printf. So this program is to print the sum of two numbers. So ask the user enter two numbers. Enter two numbers. Now scanf, enter one number. Enter one number. That's because I have already specified the value of a is equal to 50. I only don't know what is the value of b because I have declared it here, right? Just write enter one number. Take the scanf and take the input for b, which is %d and b. Done. So now user will enter some value for b, let's say 100. So now I have value of a is equal to 50, b is equal to 100. So calculate sum. Sum is equal to the variable sum, which I initialized here, a plus b. This is arithmetic operator, a plus b, and this is assignment operator. Done. So that is the reason you should know all kind of operators. If this much is done, now print the value of sum. Printf sum is equal to, as I told you, have to write the format specifier wherever you want to print the value of a variable. Sum is equal to %d, double quotes close, and write the value which you want to print. The sum is stored in the variable called as sum, sum. Done. Done. And then you have to return some value to the function, return 0. Return 0, close. Return keyword is used to terminate a function, or it is used to return some value to the function. Okay, for int main you have to return 0 so that the termination ends. This is the program to add two numbers. See here, I wrote the documentation section, I also wrote the link section, I wrote definition section, I wrote global declaration section, I also wrote main section. The only section that I didn't write is subprogram section, which I'll explain you in functions chapter. Okay, for now this is the program. That's it. This is how you write a C program to perform addition of two numbers. Simple. If you know printf, scanf and operators, you can write any program of your choice. So now I'll write you one more program to calculate simple interest. Let's write the program to calculate simple interest. I'll start with directly link section, no documentation section, #include stdio.h. Okay, then come here int main. Let's do everything inside main now. See, if you people know, simple interest is equal to p into t into r by 100, right? So what are the variables I need? I need variable called as principal, I need time, I need rate of interest, and I need a variable to store the answer. That's it. P into t into r by 100. What are the values? I don't know. I don't know the value for p, I don't know the value for t, I don't know the value for r. So ask the user, printf, pf means printf, enter values for p, t, r, right? Principal, time, rate of interest. He's gonna enter the value in scanf. SF means scanf, you have to write full, don't write like me. Printf means pf, you have to write full thing. First one is principal, the second one is time, and the third one is rate of interest. Percentage d, percentage d, percentage d. First variable is and p, then write the and t, then write and r, p, t, r. Calculate SI. SI is equal to, you can use brackets, p into t into r, okay, p into t into r, then write divided by 100. If you know arithmetic operators, this is very simple. After that, printf, simple interest, SI, simple interest is equal to percentage d, right? Simple interest is equal to percentage d. But tell me, if in is there any possibility that this can hold some decimal values as well? Have you ever seen in your account, you will see like 1023.23. This 23 was the interest, okay? So it can be a decimal number. So instead of using SI as an integer, let's use it as a float SI, okay? This will hold a floating number decimal. So here instead of percentage d, here instead of percentage d, use percentage f. That is, simple interest can be floating number, percentage f, and print SI. Done, right? Done. So first one is, so first one is, I initialized 3 integer numbers and I initialized 1 floating number, SI, and I calculated SI is equal to p into t into r by 100. Then I printed simple interest is equal to percentage DSI. Then close the main, return 0, and then don't worry about return keyword now. Just don't worry about it. Follow the pattern just by heart. In the functions, that is, once I complete these things, I'll go to functions, there you will get to know. So this completes structure of C program, C tokens, data types, input output operations, and also how to write a program. So we are done with this part. I hope all the contents till now are clear. If you know this much, you know 30% of C programming. Trust me, you know 30% of C programming if you know this much. Before continuing the video, note down the time, what is happening for this video right now. Go back, just study all of them, just revise them once, and then continue to the second part, that is control statements, okay? Because this is a bit complicated topic. I don't want you people to rush, okay? Take a break and come back, okay? So now I'll continue with control statements. So let's continue. So the next topic is control statements. Just give me a second. Control statements, okay? And from here on, this is level 2. If you don't know all the topics that I've told you now, starting from structure of C program to input output operations or C tokens or whatever it is, it will become hard for you. So please don't continue watching this video if you have not seen that. First understand everything, then come here, okay? So let's try to understand the meaning of control statement first, and then understand what are the different types of control statements available. First of all, let's see, you are going on a road, okay? You are going on a road. Now you have 3 different paths to take. 1, 2, 3, okay? 3 different paths to take. If you pick one path, if you pick this path 1, these 2 paths will be gone, right? Once you have done the path, you are going like this, and you take this path. So this is called as control statements, where you will have multiple parts of your program. This may be 4 lines, this may be 4 lines, this may be 4 lines. You have to make a decision. Which particular segment should I have to execute. The moment you execute one, the other 2 segments will be done. It will be removed. And when you're done with execution of this 4th line, you'll directly come here and start the execution after the next line. Such kind of situation is known as control statements, where you pick if this particular condition is true, what kind of statement should I execute. This is called as control statements, okay? The statements which are used to control the flow of the execution of C program. Control statements is nothing but a statements which are used to control the execution of C program. This is the concept. This is a theoretical concept. That is, if you pick one particular part, other parts will be ignored. For that, the first one is simple if. Simple if. Okay, the syntax is you write the keyword if, in the brackets you write the condition. That is, if this particular condition is true, I have to execute if part, open a bracket, write the true conditions. If is true, what are the statements I should run, and close the flower bracket. This is simple if. And the best example is, start from main. You have to write hash include stdio.h. If you write, you have to write hash include stdio.h. Okay, I'm not writing it. You say you have a variable a comma b, int a comma b. I initialize the value of a is equal to 20, b is equal to 10. Using if, you can check if a is greater than b, right? You can check this condition. If a is greater than b, you can printf a is greatest. A is greatest. Done. Close the main, return 0, and done. This is how if statements can be used. That is, if 20 is greater than 10, only then compiler will enter this bracket, execute this particular segment, and come out of this bracket. If a was 20, b was 200, 20 is not greater than 100 kabatti, compiler will skip this line, and directly compiler will execute from here. This is if statement, simple if. The second one is if else. If else in simple, it is just like a coin, tossing a coin. One side of the coin there is head, one side of the coin there is tail. Okay, if you get head, tail will be ignored. If you get tail, head will be ignored. Either one will be executed. For that, the syntax is if condition. If you write the condition, then open the bracket of if, write the if true segments, or else. See, when you write else, you need not write the condition again, because the moment you toss a coin, if you get head, you already know that the other side is tail, right? You need not check it. So that's the reason for else segment we don't have any condition. Please make a note of it. In if we have a condition, for else we don't have a condition, and if and else are written in pair. First you write if, then you write else. Example is, continue the same program, main, okay, int a comma b, same example, a is equal to 10, b is equal to 20. Now if a is greater than b, printf a is greatest, right? And what is the syntax of if else? After if, you have to write else, directly else, open the bracket, printf b is greatest, close, return 0, close the main. See here, what happens is, a is greater than b, is 10 is greater than 20. No, so this particular line will be skipped, this particular line will be skipped, directly compiler will come to the else part, and it will execute this line. Is it clear? This is how if else works. And why are we not writing a is greater than b, else b is greater than a? Does it make any sense to check this statement? If a is greater than b is false, then definitely b is greater than a. See, we need not write any conditions for else part. Is it clear? If else, and if else is mostly used if there are only two variables, or if there are only two cases for the given problem. That is, if a given number is even or odd, if a given number is prime number or not, if the given number is a leap year or not. Yes, in such kind of situations we use if else control statement. So we are done with if statement, we are also done with if else control statement. The third one is else if ladder. So tell me, if there are three numbers a, b, c, and you want to find which one is the greatest. That is, if there are three numbers, else if ladder, and you want to find which one is the greatest number. For that, can you use if else? No, not possible. In such kind of situations, we may go with else if ladder, where there are more than two outcomes. The syntax is first one is common, if condition, okay, bracket open, bracket close, both all if, else if ladder and nested if, everything are gonna start with brag if only. After that you write else and again you write if condition. See here, you wrote else, then again you wrote if, bracket open, bracket close. You can write n number of else if ladders. Else if condition, bracket open, bracket close, and finally end with the else part. This is the syntax for else if ladder. If condition is true, this lines will be executed. Else if, sorry, if condition is true, I'm sorry. Yeah, if condition is true, these 3 lines will be executed. Else if first condition is true, these 3 lines will be executed. This will be skipped, or else this 3 will be executed, other 3 will be skipped, or these 3 lines will be executed, other 3 segments will be skipped. This is else if ladder. Example program is main, and there are 3 variables now, int a comma b comma c, where a is equal to 20, b is equal to 10, c is equal to 50. Now we have to find the greatest of 3 numbers. So let's start. If now we are using logical operators and or not. This is logical operator. If a is greater than b, that is a is greater than b also, and a is greater than c also. A is greater than b and a is greater than c. If this condition is true, printf a is greatest, right? First case is done. For a, we are done with the condition. The second one is else if b is greater. For that, if b is greater than a and b is greater than c. If a is greater than b and b is greater than c, printf b is greatest. Done. Last condition is directly you can write else. That is, first, as you people know, structure of C program, execution starts from here top to bottom. A is also not greatest, B is also not greatest. By default, C is greatest. Write directly in else if, in else part, C is greatest, and done. This completes your else if ladder as well. This is the third type of control statement. Is it clear? And the fourth one is nested if. And the fourth one is nested if. In case of nested if, what happens is, just imagine a pregnant lady, okay? Life inside a life. In the same way, what happens is in nested if, inside the if condition brackets, we will be having another if condition. Like this. This is called as nested if. Inside the if, you can have if else ladder also. You can have nested if, anything. But inside if, you have to encounter another if. Example is main. This is to find the greatest of 3 numbers only. Int a comma b comma c. Write like this. A is equal to 20, b is equal to 30, c is equal to 40. Any 3 numbers. You can use scanf to take the inputs. I don't want to waste time, so I'm giving like that. If a is greater than b, that is, if a is greater than b, open the bracket. Yes, a is greater than b, true. B is not greater. Check again. If a is greater than c. See here, inside the if, we are writing one more if. Printf a is greatest, right? A is greatest, because a is greater than b, a is greater than c, a is greatest. Else not. Inside if only write c is greatest. C is greatest because a is greater than b. Fine, which means b is the small, and you are checking a is greater than c, which is false. That means c is greatest. That's it. If a is greater than b, b is not greater than a, definitely c is greater than both a and b. That's the reason I wrote it like this. This completes the if part. This completes the if part. In the same way, you will have to fill for other conditions. Check else if. Check else if. Is b greater than a? The second condition. Is b greater than a? If true, inside b check if b greater than c. If this is true, print b is greatest or print c is greatest, right? Or in the else part, you can check the last condition. C, you have to check for c. Is c greater than a? C greater than b. Definitely c will be greatest. So this is how you will use nested if, that is if inside an if, or if inside else if. That's it. Okay, this is called as nested if. So these are the 4 types of control statements using if. After if, there is a one more important topic called as switch. Switch is just like your room switches. Okay, if you press one button, the other button will be ignored. But here what happens is there will be n number of buttons. Okay, the syntax for switch is you have to write the keyword switch and it will take a option. What option you want to execute. For switch you will have to pass a single option. If in case for the option you have to write case means if that particular option is triggered, what should I do? Case 1, for option 1 I'll have to perform these things. If the case option value was 2, I have to perform these things, come down. If the case option was n, I have to perform these things, or else default. If the entered option is invalid, I have to perform default operations and come out. This is the syntax for switch. This is the syntax for switch. Is it clear? This is the syntax for switch. And example is let's write a program to perform arithmetic calculator. Arithmetic calculator main. Okay, now we need to have an option. Then we need to have two numbers for which we have to perform arithmetic operator. Printf, enter two numbers. We are taking input for two numbers. Scanf, %d, and a comma and b, Then now printf, enter your choice. You have to ask a choice, right? 1 for addition, 2 for subtraction, 3 for division, 4 for multiplication, like this. Now scanf again, %d, and take the input for op. Done. Now call the switch. switch, give me the option. Once the option is entered, now you have to check case. What is the case? First option is he entered the number 1. Case 1, printf sum is equal to %d a plus b. Done. Okay. Case 2, let's assume his choice was subtraction. Sub is equal to %d a minus b. The third one is, you know already, let's say for multiplication you wrote it, for division also you wrote it. Okay, he entered something else. Instead of entering 1 2 3 4, he entered some other input. For that you have to use the keyword default and write printf invalid. Done and close. This is how you write switch. But there is a problem with switch. The problem is, once if switch enters into a case and it executes this much, okay, it has the habit of continuing the execution till the end of the bracket. It won't come out like if else. It won't come out manually. In if else, if one condition is true, others will be skipped, right? But here it won't stop. To make it stop, we have to use a keyword after each case called as break. You have to write break before starting the next case. Break. So once break keyword is encountered, it will directly come out of switch. Okay, this is how you write switch. Then write return 0 and close. This is switch statement, which is also a control statement, which is used to make a choice. The only thing is, in case inside the case, you can't write something like a greater than b, a less than b, nothing. You have to give one particular value, one definite value. That is the only drawback of switch. Okay, you have to give a value like case 1, case 2. In if you wrote something like a greater than b, a less than b, that won't work in switch. So these are the 5 different types of control statements. I hope this topic is also clear. Fine. The next one is called as looping statements. Also known as iterative statements. I'll explain what are these now. Wait. The next important topic is looping statements. So first of all, let's understand what is a loop. If this is the starting point A, we take a journey, we go wherever we want. If we reach back the same starting point from where we started, this particular journey is called as a loop. Okay, this particular journey is called as a loop. Reaching back the starting point wherever you came from. If you think about your school days, you used to start from your home, go to school, Sodi anta Vini will come back to home, right? That one particular cycle is called as a loop. And if you want to repeat the statements n number of times, such kind of things is called as looping statements in C. In C program, you would have written some statement that you want to print or execute again and again. In such kind of things, we use looping statements, and there are mainly three types of loops in C program: for, while, and do while. Okay, so now let's see one by one. For loop. So for loop, we have three segments in the syntax. This is the syntax of for loop, that is for. In the first segment, you initialize the value of the loop. It may be I is equal to 0. I may be the variable that you are using to start a loop. Okay, and I less than 10, that is until I value is less than 10, you want to execute the loop again and again and again. That is starting from the value of I is equal to 0 and the last value I is equal to 9, you want to perform the loop. And the third segment is called as increment or decrement, where you can increment the value of I or you can decrement the value of I. So what happens is, when I is equal to 0, we enter into the loop, execute this part. Next, the value of I is incremented, I becomes 1, and then we check if I is still less than 10. If yes, we'll enter into the second loop. Then again I plus plus, I becomes 2. Check if I is less than 10, 3, 4, 5, 6, 7, 8, 9. Once it is 9th time, we come again. I becomes 10, we will check if 10 is less than 10, that is I is less than 10, the condition is false, we will come out of the loop. This is for loop, where the first segment is the initialization part, the second segment is the termination part, the third segment is increment or decrement part. To show it practically, we can write something like this: main. Okay, inside main we have some variable called as int I, that's it. For I is equal to 0, I is less than 10, I plus plus. I'm just showing the demonstration. If you want full video of for loop, you can just go to looping statements and watch the video. I don't want to waste my time. You just printf value of I is equal to %d /n comma I. Done. Return 0. Close the function. So what output you are gonna get is, output screen will look something like this: value of I is equal to 0, I is equal to 1, 2, 3, so on up to I is equal to 9. Same line: value of I is equal to 1, value of I is equal to 2, 3, 4, 5, value of I is equal to 9. This is called as for loop, where for loop will have the initialization segment, termination segment, as well as increment and decrement segment. Okay, the second loop is while loop. In case of while loop, what happens is the syntax is a bit different. We will have a syntax while, and here we only have termination condition only. Until the condition is true, while loop is gonna get executed. Unlike for loop, we don't have initialization part, neither we have termination part, I mean increment or decrement part. We have only this particular thing will be written, that is while. That is while I is less than 10, only this much will be written in the while condition. You won't have increment, decrement, nor you have initialization. This is while loop. So if I have to write the same program, this will look something what different. You have int I, we have int I. So before starting the loop itself, you have to initialize the value of I. For I is equal to 0. Then start the while loop. While I is less than 10, printf same program, value of I is equal to %d comma I. So what happens is, we will come here, the value of I is initially 0, the condition is true, we'll come here, we'll go back, we'll be keep on repeating like this without any end, because we don't have increment operator, right? I plus plus is not there in while. For that, inside the while, you have to manually increment the value of I as I plus plus. So now what happens is, we will come here, we'll print value of I is 0, then we increment the value of I is equal to 1. So next time I becomes 1, 2, 3, so on up to 9. So 9 times it is going to execute, 0 to 9 10 times, then we'll come out of the loop and return 0. Done. This is while loop. A small change for loop, that is for I is equal to 0, this is pushed to the top, I less than 10 remains, I plus plus will be pushed inside while loop. So just remember, push it up, push it down, just imagine, push it up, push it down. So while just looks like this: while I less than 10, I is equal to 0 is pushed up, and I plus plus is pushed inside while loop. That's it. This is while, and both for and while loop are called as entry control loops. Both are called as entry control loops because if the condition is false, that is if I is less than 10, what if I was 11 initially, we set the value of I is equal to 11, that is for I is equal to 11, I less than 10, I plus plus, while I is less than 10, where I was set into 11, we won't enter the loop even once. Until the condition is true, we will never enter the loop. So initially, before entering the loop itself, we are checking the condition if it's true or false. In such kind of loops, these are called as entry control loops, and the number of iterations, minimum number of iterations possible in such kind of loops may be 0, 2. Okay, 0 is also possible. If the condition is false, we will not even enter the loop. That's it. In the same way, we have third loop called as do while loop. Do while loop, and do while loop is a bit different one. The syntax is do me this task first and then check the condition while condition, and we have semicolon here. For please focus the syntax, only in do while loop we have semicolon at the end of the loop. Neither in for loop we have semicolon here, neither in while loop we have a semicolon here. Just remember this thing. Okay, the syntax is same. Now write the same program. Same program. Start from main, int main. Okay, come here. Now you have to initialize. Let's say we have variable int I. Okay, int I, and I'm initializing the value of I is equal to 20. I is equal to 20. Now write do printf. I'm writing the same program. Value of I is equal to %d, and I'm printing the value of I. After that, I am writing my while condition. I is less than 10. Okay, return 0 and close. See what happens now. Compiler will come to I is equal to 20. It is gonna set the value of I is equal to 20. It is gonna enter the do. See, there is no condition here, right? Do syntax doesn't have a condition here, so directly it is gonna enter the do while loop. It is gonna execute the body at least once. It will print value of I is equal to 20. Then it will come out of this segment. Then it is gonna check is I less than 20. Is 20 less than 10? The condition is false. It will come out here and it will end the program. But even though the condition was false, we got output at least once, right? So the minimum number of times the do while loop will execute the body is minimum 1. Unlike for loop and while loop, it's not 0, it is 1, and the condition is checked after coming out of the body. So this is called as exit control loop. Okay, this is not called as entry control loop. For and while are entry control loops. Remember, do while is a exit control loop. This is the most important difference. I want you people to learn for and while more than do while. Okay, learn at least for and while. You should be using for and while to write the programs. Don't learn do while now. You people are not that good enough to use do while because it's a bit confusing. So just study for and while. With this, one second. With this, we are done with control statements. We have completed if, we have completed if else, we have completed else if ladder, we have completed nested if, we are done with switch, and in loops we are also done with for loop, while loop, and do while loop. Only topic that is remaining is functions, that is functions and recursion, which I'll be doing now. Before going there, please make sure you don't have any doubts here. If in case you want more elaborative explanation on any of this, all the videos are available in this YouTube channel. Go there, learn them more and come back. Okay, this should be your clarity. So please go there, study all of them. Even you should be clear with all of this. And then come to functions. Okay, so now I hope you people understood whatever I told till now. All the videos are available in this YouTube channel. Go there and study if you want more knowledge about this. Okay, so now I'll continue functions. The next topic is functions. In functions, we have to discuss 4 different topics. First one is what is a function, what is the meaning of a function. Second one, how to pass parameters into the function, passing parameters into the function. Third one, calling a function. And last one is recursion. So these are the important topics that we need to discuss in functions. Okay, first of all, What is a function? Function is nothing but instructions block. Function is nothing but an instruction block developed or created to perform one particular task. Like in example, if we talk about main is an inbuilt function. This particular function was developed to execute the program, right? To execute the program. As you all know, main is the stomach of C program. Everything that you write inside the main is instructed to be executed. The execution starts from main. This is an inbuilt function. In the same way, we can create our own user defined functions. Before going that, I want you to give a small memory of structure of C program. See, the first part talks about documentation section, second one talks about the link section, third one talks about the definition section, fourth one talks about the global declaration section. After that, the two sections, these two talk about the functions. The inbuilt function is called as main. Okay, this is also a function which you people know. Now we have to talk about subprogram section. Now we need to talk about the subprogram section. Is it clear? So what is subprogram section? In this section, user can write his own functions which can be developed to perform one particular operation. If I have to give the syntax of a function, first let's talk about the syntax of a function. It consists of a return type. Then the name of the function. Then we pass the parameters. This is parameters of the function. Inside that, you can declare variables, local variables. Declaration is also allowed. Then you can write the statements, that is the equations that you need to execute. Statement 1, statement 2, so on up to statement 10. There will be a return type. Okay, you will return some return value and an expression. You will return an expression and done. In simple example, we can write a function like this. Void. We can create a function to add two numbers which will be passed using main. Int a comma int b. Okay, it takes two parameters, and what does it do? It printf sum is equal to %d a plus b. Done. In the same way, how to call, this is how you create a function. If I have to give one more example, we can write something like this. Int subtraction, which will perform subtraction of two numbers. You will write int a comma int b. Okay, then you write printf difference is equal to %d a minus b return 0. This is one way of writing the return program. Or you can write something like this. Int multiplication, this particular program will perform multiplication of three numbers, int a comma int b comma int c. Then you can directly return a into b into c. This particular value will be returned to the calling function where this particular function was triggered. So this is how you write a function. Okay, this is how you write a function. To give one full example, you can write like this: hash include stdio.h. Then you can write something like int main. Here you have two numbers. Say int a is equal to 20, b equals 10. Okay, then you call the function called as add of 10 comma 20. Done. Return 0, close. The moment you write add, you have to write here void add int a comma int b. You have to always write the prototype, that is you have to write the first line of your function in before the main, and you have to write semicolon. This is called as prototyping, which is compulsory. After that, you can write your function here, which is void add. See, we are passing two numbers. The first number is 10, which is of the type integer, and we need a variable to store the value 10. So 10 will be stored in int a, and second parameter is 20, which is also of the type integer. Then come here, you can write printf sum is equal to %d a plus b. This is how you write a function, and this particular section is called as subprogram section. To get more clarity about this, you can watch the functions video. Okay, you can watch functions video, there you have it. And how to pass the parameters. Passing the parameters, there are two ways of doing it. Either you can pass the actual parameter like this. This is 10 comma 20, or you can pass directly like add of a comma b, anything. This is called as passing parameters, and these parameters which you pass are called as actual parameters. Okay, where you are passing the copy of the variables, and this particular thing which receives the parameters is called as formal parameters. This is called as formal parameters. If in case you want to get more clarity on this, you can watch the functions video. I won't be explaining much about functions in this particular topic. Since it's a speed run, it will take me around 40 minutes, which is a time waste. So please visit the functions video that I have posted in this channel and you can continue. Okay, so now I'll be discussing in depth about recursion. Let's start recursion. If you know about this much, it's more than enough. If you want more clarity about functions, watch the functions video. Okay, now let's discuss about recursion. One of the most important topic, recursion. Okay, recursion is one of the most complicated topics that you may encounter in C programming because the tracing method is completely different than what it is till now. Okay, so first of all, let's understand what is recursion. If you have a function called as int add of two numbers, that is int a comma int b, just as an example, don't take it seriously, and there are n number of functions in the return statement. In the return statement, if the function is itself calling it once again, if the function is calling itself again, this particular type of problem is called as recursion. That is, function is calling itself inside the function. The same function is calling itself again and again and again and again and again and again. And one of the best examples to represent recursions is nothing but looping statements. If you remember the looping statements, for loop, while loop, do while loop, in the same way, they were also repeating themselves again and again, again and again, again and again, again and again, until a set of constructions or instruction or some termination statement was executed. This is also the same type of problem where the function will itself call itself again and again and again and again and again until a condition gets satisfied. This type of problems is called as recursion. Okay, this is recursion, function calling itself inside the function body. So let's try to understand this with an example. So let's write a C program. Let's write a C program that will print first n positive numbers, in decreasing order. That is, if we pass the parameter as 5, it should print 5, 4, 3, 2, 1 using recursion. Okay, this will help you understand it better. So let's see here, hash include stdio.h. okay, int main, let's go to the main function, and in the main function let's call the recursive function, that is my printing function nat, which stands for natural, and I'm passing the number 5. Okay, I'm just passing the number 5. So see here what happens. My nat function, int nat, is nothing but taking an integer number of int a. Okay, I have to print it in reverse order. So printf percentage d comma a. That's it, right? I printed the number, so this will print me 5. So now I have to get 5, 4, 3, 2, 1 as well. So what I'll do is I'll return, in the return function, I'll again call the nat itself, nat, and I want to print the 4 next, so it is a minus 1. I'm decrementing the value of a. That's it. So what this function does is, this is the simplest function, this is a recursive function. So see here, initially nat of 5, that is 5 was passed, it printed the value 5, and next time we are calling nat of 5 minus 1. Okay, nat of 5 minus 1. So what this will print is, this will print 4, and again it will call for the function nat of 4 minus 1. What this is gonna do, it is gonna print 3, and again it's gonna call the function nat of 3 minus 1. Next time this is gonna print 2, and it's gonna call another function nat of 2 minus 1. This is gonna print 1, which is the first natural number, and the execution should have stopped here, right? The execution should have stopped here, but if you observe this condition, there is no termination at all. There is no termination. This is also something like an infinite loop. This is an infinite recursion. It will call for nat of 1 minus 1. It will print 0. Again it will call of nat of 0 minus 1. This is called as infinite recursive problem. To come out of the recursion, we should have some set of functions. Like if you take a for loop, for I is equal to 0, we have something like I is less than 10 or I is less than 20, when for loop will end. In the same way, recursion doesn't end in that pattern, but recursion can be ended in a different way. So I'm writing the same nat function, but this time I'll make a small change. Okay, see here, the first number it is gonna print is the given n number, and the last value that it should print is 1, because the first n natural numbers in decreasing order are 5, 4, 3, 2, 1. That's it, right? So you have to check multiple conditions. If a is equal to 1. That is, let's assume we did so many iterations and now we are here, we reached here. If a is equal to 1, what you need to do is printf, print the value of a, percentage d, and print the value of a. Now return 0. You people know, right? Return 0 means end of the execution. Or else there may be one more condition. Else if what is the user by default, instead of passing a positive number in nat of 5, he passed something like nat of -5, or he passed something like nat of 0, which are illegal. So else if a is less than or equal to 0, you have to check if the condition is true or false. Printf invalid number. You have to print it as well. Invalid number and return 0. We are ending the execution here itself. If in case we get 1, we'll print the value and close the function. If in case the user entered 0 or -1 or -5, something like that, we are showing invalid. Else call the return function. Return, before return, write printf percentage d space a, print the value of a, then call return of nat of a -1. That's it, nat of a -1, and this closes my function. So see, now we have two termination conditions. Let's try to trace this program with this example. It passes nat of 5. We got nat of 5 here. Now is 5 equal to 1? Is 5 equal to 1? No. Is 5 less than or equal to 0? No. So we'll print the value 5, and then we are gonna call the function nat of 5 -1. Now come here. Now check. Is 4, now a is 4. Is 4 equal to 1? Again no. Is it less than or equal to 0? Again no. So print the value of 4. Again call nat of 4 -1. Now it is 3. 3 is neither equal to 1 nor it is less than 0. Print nat of 3. Then call nat of 3 -1. This is how you have to trace a recursion. Next time nat becomes 2. It again calls for the function nat of, nat of 2 -1. Again you call the recursive function. Now it is 1. See here, it is 1. We printed. Now what happens? A became 1. If a is equal to 1, printf percentage the value of a. We printed the value of a here. Next, what is the condition? Return 0. This will return 0 to the main function. This will return 0 to the main function, which means the termination ends here. We are not calling the return function again. We are ending the termination. So what did we print? We printed 5, we printed 4, we printed 3, we printed 2, we printed 1, and we terminated. This kind of problem where the function calls itself again and again and again and again and again is called as recursion. Okay, this is one of the important types. I'll give you one more example for recursion. Let's try to find GCD of two numbers, greatest common divisor of two numbers. Before writing the function, I want to show you something. There is something called as Euclidean method of finding GCD. Euclidean method of finding GCD. This is the most simplest form of calculating a GCD. That is, if there are two given numbers, say a comma b, you just have to keep on calculating. First you have to pass the parameter b, then you have to calculate and pass the parameter of a by b to the next function, until and unless a modulus b becomes 0. If a modulus b becomes 0, this first parameter will become your GCD. I'll demonstrate it. See here. Let's find GCD of 10 and 3. Okay, 10 and 3. According to the condition, what I should pass in next time, I have to call the function GCD again, but this time pass this as first parameter and calculate 10 modulus 3, which is 1. 10 divided by 3, the remainder is 1. Pass it as the second parameter. Now calculate the GCD again. Now 1 comes here. We have to calculate 3 modulus 1, which is equal to 0. 3 divided by 1 is 0. As I told, if we get 0 here, we have to stop here and this number becomes GCD. So GCD of 10, 3 is equal to 1. That's it. This is Euclidean method of doing this. Formula is very simple. You keep on passing the second number first. If there are n1 and n2 two numbers, in the second iteration you have to pass n2 comma n1 modulus of n2 until this number becomes 0. If this number becomes 0, n2 is your GCD. This is the concept Euclidean gave, a great mathematician. I'll show you again. GCD of 20, 5. Let's assume 20, 5. What am I passing? I am passing n2 first, 5, and I am then passing 20 mod 5. 20 mod 5 is 0. You can see here it became 0. We have 5 here. So nothing but 5 is the GCD. That is GCD of 20, 5 is equal to 5. Okay. I hope this is clear. So now let's write the recursive function. That is int GCD int A comma int B. Now let's write the termination condition first. If this number, if it becomes 0, we have to terminate. If B is equal to 0, if B is equal to 0, printf GCD is equal to %d. We have to print this as the GCD, right? According to the formula. That is what Euclidean gave to us. %d, A is the GCD, return 0. Return 0. End the program. Else this means that B is not 0 yet. B has some value like 5, 4 or some value. What should we do? We have to return or call the function return GCD of call return function GCD of what is it? First pass the second number B, then pass A modulus B. Done. Close. This is the recursive problem. This is the recursion problem to print GCD of two numbers. That's it. Recursion is this simple. You just have to understand how to end the program. Let's trace this. Let's say I pass two numbers, GCD of 30, 7. Let's assume I pass something like GCD of 30, 7. Initially 30 comes here, 7 comes here. Is 7 equal to 0? No. What should I pass? I should pass B to B first. 7, 30 modulus of 7. 7 3 is a 20. What will be the answer? 7 3 is a 21. 7 4 is a 28. 2 will be the remainder. Right? 2 will be the remainder. Yes or no? 2 will be the remainder. So now 7 and 2 are gonna come here. Sorry. Yes. 7 and 2 are gonna come here. Is 2 equal to 0? Is 2 equal to 0? No. We are again calling the GCD function. This time 2 comes here and 7 modulus 2. What is the answer of 7 modulus 2? Remainder is 1. So 1 comes here. Again GCD function is called because this is not 0. GCD of 1, 2 modulus 1, that is equal to 0. So it becomes 0. Now this condition satisfies. We print the GCD as GCD equal to %d of A. A was nothing but 1. So GCD becomes 1 and we end the termination. So this is how you trace a recursive problem. This may look difficult for you people at first attempt, but if you keep on trying, you will get a knack of it. See, tracing a recursive problem is not that simple. It's not like you wrote I is equal to 1, n I is less than n, I plus plus, and tracing like for a table. This is not a loop. You can't trace it like a table. You have to trace it in this manner. Okay. So this is another recursive problem to find the GCD of two numbers. This is a Euclidean method. I want you people to first practice Euclidean method using pen and paper. After that, write the program. This is the simplest program. See, GCD int A comma int B. If B is equal to 0, A becomes, this particular thing becomes the GCD. End it there with return 0. Else return GCD, call the recursive function again. Remember, to terminate a function, you always have to return anything other than the function name. If you return a function name, the function is gonna get called again. But if you want to end the function, you can return 0, you can return 1, you can return any number, you can return any value, you can return any expression, anything is possible. Even you can return -1, -2, etc. But never ever return a function name again. If you return a function name again, instead of terminating, you are calling a new function call, and again that particular thing will be executed. So to exit from a recursion, you always have to end it with a value. Is it clear? So if this much is clear, we are done with recursion. So in this problem, I showed you how to calculate GCD using recursion because this is an important problem. I want you people to try writing recursion for finding the factorial of a number. try it yourself to find the factorial of a number. If not, if in case you get stuck, you can go to Geek for Geeks. There you will find the program for this. And understand, if in case you have any problems, like if in case you have any doubts, you can contact me at my Telegram ID, that is Pawan_Prakash_VBIT. If in case you have any doubts in any topics that I have taught, I'll be more than happy to help you out. Okay, so have a great day. Bye bye. This is my Telegram ID. You can contact me directly here. I'll definitely help you out. Okay, Jai. Bye.